Okay, so thanks for being here. Happy Thursday of week 4 of the semester. Um, so in terms of things that are happening, there's not only a panel on grad school tomorrow, there's also summer research student talks. Wait, how did that happen? Um, did anyone here participate in summer research this year?
I tried.
I'm sorry.
Like we don't have funding for you.
I'm sorry.
Yeah.
Um, Well, if you would like to go, if you know anyone who presented and you would like to go support them, or if you're like, what is summer research?
Is it like screen research? Can I do screen research?
I do not know. Although some professors, like,
It's a good time.
I mean, okay, so for professors have to do research as some professors have to do research as like part of their contract. And so I think some professors are like always looking for students. I'm looking for students. I don't necessarily have funding at the moment. I'm working on that. But if you're interested in a research project around like 3D printing, come let me know.
Yeah, because they told me like, yeah, you can do research, you need to find funding, and then they told me like, yeah, we have no money, all our money's gone. But
I'm sorry. Yeah. Yeah. It happens. It happens. But anyway, for this event, if you want to go support the students or learn about what happened, that's I think they're supposed to be like 3-minute talks and super accessible to undergraduate students. Just if you show up and people are talking, just wait till you enter. It's like when I was learning violin, they taught me like concert manners where like if you show up late to something, then you wait till they clap. And then once they clap, then you can walk in and like sit in the back, something like that. But yeah. And then the other thing happening tomorrow is panel on grad school. If you're interested in that, if you're still like at the wondering stage, it's worth it to go and find out like here's what grad school is about and try and start that process of thinking about that early. They might have things that are more geared to like students who are actively starting to apply, but you can just go show up and see what's involved with that process.
that's like, what season for it.
Now,
So what?
usually maybe like January, February. It's like typical, like, yeah, so yeah, now until like, I think mine were due in like January. Yeah. Um, okay, any other comments, questions, concerns before we start today? Okay, seeing none. We are going to finish up the combination lock and then move on to bigger and better things. Okay, so what we did last time, we set up constructors. We have a 3-parameter constructor. We also have, I'm gonna fix the lights here. I feel like it's too bright. Is that better?
Yeah.
Okay. Okay. All right, so we've got our 0-parameter constructor where we just use this keyword to call the constructor that we wrote earlier. So we gave it 0, 0, 0, and that calls combo lock of 0, 0, 0. We have what we call why did the dictionary open? We have what we call a helper method to check the combination. A conversation we could have is, do we want this combination? Do we want this method to be public? Talk to your neighbor for 5 seconds. Do we want this method check combo to be public? Go.
Yeah, it's same that.
Okay, what do we think? Who votes for public? Who votes for public? Who thinks this method should be public?
So public means it can be accessed by other. No, this gotta be private,
Why?
because you don't want someone else to like check to see whether the combo is correct or not.
Yeah, yeah. So exactly. So the idea is if we're in another file, another .java file, and we have a ComboLock object, we don't like if we call it C, we don't want to be able to say C.check combo and give it numbers. Like we only want to be able to check the combination in the open method or the change combo method.
Open method is public, doesn't it not make a difference whether this is public or private? Because they both essentially do the same thing, right, which is check the validity of the pre-integers.
So yeah, so it does matter because the open for us, the open method is actually doing the opening, right? It's doing this process of opening the combination lock. Check combo just returns true or false, whether or not the combination you gave was correct.
Are we just using this to save space later?
So I'm not sure. I'm not sure about your question.
Because like, feels like any method you create where you have to check the combo, you'd have to have this line of text in it, right? Just let everyone.
So yeah, so we've created this check combo to prevent us from having to type this all over again. But once we have this method, I would argue that we want this to be a private method, so a helper method that we call within class methods. So like in open, we can call check combo to help us out instead of having to type that code here in this if condition. But we don't want it to be public in and of itself because that allows some outside class method to try and check the combination, which we don't want to allow. That makes sense? Cool. All right, so then we also have had our open method where we check if the lock is open already. If it is, we print something, and then we just end this method. And then if the combination they gave us was correct, then we print that the lock is open and we open the lock. Otherwise, the combination was not correct and we print it. I also realized that printf, so I think like the dot formatted works, but I think also you just need a comma there and then it does. So like for printf, I have %d, %d, %d as placeholders for these 3 integer variables. And then after the string, I just have a comma. And then for every placeholder that I had, I'm going to say, here's what you put here. Here's what you put here. Here's what you put here. So that's useful if you don't want to have to like close the string, add a plus to concatenate, open the string again. All right, and then we had a method close to check. So if the log is already closed, we don't want to close it again. That doesn't make sense. Otherwise, we don't ask for the password or anything. We just close the lock if it's open. This is our getter method for whether the lock is open or not. Do we want this to be public? Would it make sense for it to be private? No, not really. And then we've got our method to change the combination where we have a whole bunch of parameters, which are really the old combination and the new combination, where if the old combination is correct, then we can set up the new combination, make the lock closed, and then print confirmation to the user. Okay, let me see. Was there anything else that we needed in here from my notes? I don't think so. Okay, so let's just make a simple driver file. So Command Shift P and then the new Java file and the class, and I'll call it ComboLock driver. And in here, I'm just gonna have a very simple main. So if I start typing main and then hit enter, there's my main. And I'll say ComboLock C is equal to new ComboLock. And let's give it an initial combination of 1, 2, and 3. If I try and open it, let's try and open it with 0, 0, 0 first. Because that's going to fail, right? Because the combination is not 0, 0, 0. If I give it 1, 2, and 3, that should succeed, right? Because the combination is 1, 2, and 3. So, okay, let's print that. Let's run that and see if that happened. Okay, so let's see what happened. Said combination 0, 0, 0 is incorrect, and then prints lock is open. So there's no new line here. So let's go back and see what happens. So if we go up to open, aha. So the thing with printf, so println, which we've been using mostly, that adds a new line at the end of your once it's done printing. So you print something, and then it adds a secret new line. So anything you print after is on its own line. Printf does not add the new line automatically. So if we want that behavior, we need to give it \n at the end of the string. And that's a special character so that it'll know, okay, like hit enter and put the next thing we print on a new line. So if we add that and then go back to the ComboLock driver, now we get the incorrect combination and then the lock is open. Bless you. Okay, so now let's try and close the lock and then let's do change combo. Let's try and change it from 1, 2, 3 to 4, 5, 6. Okay, so once we do that, so the lock gets closed. Some things to note as we, like, this is a very bare bones implementation. We don't check if the lock is closed already when we're doing the combination. I don't know, maybe we want to fix that behavior. But yeah, so let's take like 2 minutes and just talk about what other sorts of things. So we're pretty much done with this code, but what sorts of things could we add to it? So there's a few things that I'm looking for where are like boundary cases, like edge cases, where things that right now this works fine, but there may be some user inputs that we haven't thought about that maybe if we were going to make this more robust, we would need to implement checks and cases to handle that. So talk with your neighbor for 2 minutes. What sort of things, what sort of boundary cases are there with the code that we've written? Go. Okay, what are we thinking? What do you think what are the current limitations of our code? What could the user put in to be sneaky that maybe we're not thinking about? Yeah, welcome. Bigger than one that it can hold. Okay, yeah. So, yeah, so then in that case, maybe if the user is going to give us like a super big integer, maybe like a long, or there's in the lab, you haven't run into it yet. There's also a class called big integer that can handle like a lot bigger integers. We'll see that when we work with recursion. Um, yeah, so like we can have a number that breaks yeah, absolutely goes over the memory allotted for this. What other things? We've got integers. So are all integers allowed? Are there any integers that maybe we wouldn't want? Yeah. Yeah. As currently, yeah, absolutely. Do we want that? Maybe not. I don't know, unless we've got this super advanced combination lock that can handle negative numbers. Any other ideas? One of the things I was thinking of is, so like we changed the combination, but if we did 1, 2, 3, 1, 2, 3, is that going to give us any errors? No, it shouldn't, right? Because we just check for the combination, the existing combination to work, and then we set the new combination. So maybe we would want to add some logic to check if the original combination is the same as the new combination. So maybe we would want to add some logic there. Any other ideas? Cool. Yeah, so especially for the binary array one, there are some boundary cases that you'll have to be thinking about. And so that's how you work on iterating your code to get it to a complete-ish state, where you have some very basic code that you know works, and then you'll try and be like a hacker, where you're going to try and break the code that you have written to give it some input that maybe you didn't think about beforehand and see how that gets handled. And so once you find something that you need to fix, then you go in and add that boundary case and fix that, and then go back and try it again. So that's part of the process to like debug your program and make sure that it's working fine for whatever the project is. Okay. Any questions on ComboLock? Cool. All right, and then I need to fix this slideshow. Awesome. Okay, so we've done that. Hooray. Congratulations. So we have looked at several examples now where we have created a class in Java to model a real world object. So we've got like house.java, we've got ComboLock, we've got what other sort of things? We've got author and book in lab 3. And so I want us to try and think of what sort of things could we use this for. So we've looked at like some sparse few examples, but I want us to kind of take this opportunity to think outside the box, share with your partner what sort of things could we use classes to model. So for example, like I could model my water bottle and I could say, I could have a string for like the brand and an integer or a double for like the capacity or like the number of ounces. Uh, things for like, does it have like the silicone boot? And does it have a straw or something like that? And so all of those things could be fields, and then we could have methods like have a method like drink from the water bottle or empty it or refill it or put ice in it or something like that. So things that like, yeah, so with the thing with Java and object-oriented programming is it's used a lot for applications where you have some object that you need to store things in and then maybe update it as as things change. So that happens a lot with like web apps where like you have some data and then an event happens and you have a method that gets called for some reason. So yeah, so I want you to take a few minutes, talk with your neighbor. What sort of things could we model with classes? What would the fields be? What would some of the methods be? Okay, go.
You said banking's in Java, right?
Say that again?
You said bank accounts are made in Java, right?
Some of them, yeah, some financial institutions use Java.
Yeah. I don't think it's like.
All right, what do you think? What sort of things can we model with classes in Java? Go for it, yell it out.
Bank account.
Bank account. There is, I'm still, okay, I'm still kind of deciding. There is a homework assignment that could be, where is it? I've currently scrapped it, but we could bring it back where I think it's easier, honestly, easier than homework one.
I would swap it.
They're doing different things. They're doing different things. Where you are modeling like a bank and accounts in the bank. So where you've got a bank object that's got some fields and you've got an account object and an interest-bearing account and interest checking account. So different kinds of bank accounts. There's also like interface and abstract class, which we'll get to in a bit. No, homework one is mandatory. Yeah, what else? Different cars. What sort of fields would we have? Mm-hmm. So like the make, model, year are all fields. And what sort of methods could we have? Maybe like refill, go to the gas station. So maybe like have some notion of like fuel capacity. Yeah, cool. What else? looking for maybe two more. What about over here? What do you guys talk about? Yeah, yeah, cool. All right, one more. Someone from back there. Store inventory. What sort of fields?
Category, price.
Yeah, so this is maybe another, so I think you would need like a system of classes to model the store's inventory. So you can have like a store object. And so like maybe the store has like, I don't know, a list of employees. Never worked at a store, so I'm not sure. And like, and from there we have links to like an inventory class. Where yeah, then you can break it down more into types of like food and hygiene and textiles and stuff like that. So like yeah, so a store can definitely be represented with classes. We just have to tease it out and break it up more. Okay. Any other brilliant ideas? Okay. So we're gonna speed through the rest of this PowerPoint. We've already talked about most of it, so that's why we're speeding through. We looked at toString, where it allows us to print the state of an object. If we were going to print toString, if we're gonna have a toString method for ComboLock, wait, how do I do that? Right click, source action, and then I say generate toString. Does it make sense for me to have the fields to print the state of the object?
Yeah.
Yeah?
Yeah.
So, okay, I'm gonna do this. And then I'm gonna save this and go back over here. Now I can print C, print the state of the object. Yeah, it just does it automatically. As long as it's named or as long as it's named, where did it go? Like this, exactly like this, then it just does it automatically. So is there anything wrong with this?
No. No.
I think that is incorrect. Why would I think that is incorrect? No, there's a reason. There's a reason. Yeah. Exactly. Yeah, so I'm over here in my ComboLock driver. It's outside of ComboLock. And here I am printing the object and getting that secret information of here's my all the three numbers. Yeah.
It only makes sense if three numbers are defined in ComboLock, not defined in the driver class. Because like.
Yes, they are defined in ComboLock. And here, like we just changed the combo to 1, 2, and 3. And then we print the state of the lock, which includes here's the combination, the things that is supposed to be secret. So I think we don't want toString to behave this way. So to do that, we need to change what it returns. So this is just the default implementation. So, so maybe we print Um, maybe we print whether the lock is open. Or maybe we can add like some logic to say if the combination is something other than 000, or then we say the combination is set. And then if it's 000, then we could say maybe combination is not set. And so that way we can define the behavior of printing the state of the object. So this whole thing, totally up to us. We could take the default implementation or we can change it and write something else. So now when we do this, it just prints whether or not the lock is open. That's all it does. So the point being that when we have toString, it gives us an option to print the state of all of the fields. We can take that as it is, or we can change it. And so for ComboLock, I would argue we should change it. Okay, we looked at equals. We don't have equals implemented in ComboLock, but that is. We talked a little bit about how VS Code's version of equals is weird. So you can take that if you want or not. We talked about the this keyword, which is used to refer to our current object. Having the main method in your class, that's the only thing that's going to execute when you tell VS Code to run this file. If your file doesn't have a main method, and that's called public static void main string args, if we don't have that, then nothing's going to run. So the question is, whether do we want a main method? Let's say, do we want a main method in ComboLock? I would say no. So like we totally could. We could have add a main method in ComboLock, but the standard practice in Java is to define objects in their own file, separate, and then have a separate file that's our driver file or our demo file to actually test out the use of the object. And so that allows us to more accurately test, like, if someone uses this file outside of mine, then can they access the fields? Can they access the private things that we don't want them to access, and check that they can use the public things? So the best practice is to separate, and so have this like two different files for the main class, or the .java file, the class, and the main method where you actually are testing that object. Okay, so static is a keyword that we have seen for a bit now. There's a difference between having static as before a variable, a field, or before a method. So you'll notice, I think it was in DNA where we had, and maybe baseball too, where we had a static variable that has the string that we're going to be, like for DNA, the DNA string that we're going through. A static variable is a global variable that holds for all instances of a class. So for example, the capital I integer class has this static variable that's also final, called max value, which says, here's the biggest integer I can hold. And so static means that it holds for all instances of the class. A static method means that we can use those methods without creating an object. So for a lot of the first week or two, all of our methods were static because we didn't care about creating an object. So like for hello.java, we didn't want to create a hello object. We just wanted to do something. And so we do that with static methods. So static methods, we can use them without creating an object. But for like ComboLock, we don't have static methods because we are creating a class and then we're going to make a ComboLock object from there. And so since we want to use all these methods that belong to the ComboLock object, we don't want any of them to be static because we want them to belong to an object. And so if you're trying to use the this keyword in a static method, it's not going to work because there's no controlling object. That's the big thing. Is there a controlling object or not? Okay, this is the moment I've been waiting for. Packages. Packages are basically folders in your file system, and they're how we organize code in Java. So they're used to organize a lot of similar classes, and so each package, you're going to have probably many classes of similar type. And there are some visibility restrictions, but first let's organize our code in packages. This is another reason I don't like VS Code because in Eclipse, you can like add a package when you create a class, but here it doesn't do that for you. So I've been forgetting about it. Okay, so I've created a package called IO where I've put all of my IO files. I also probably want to move my scanner test so I can like drag and drop it up here into IO. And so I'll let it refactor it. And that when I do that, then up here it says now package IO. So once it's in a folder, you're going to have a line above your class that says package and then the package name. So let me make a folder called intro, and then I will move like hello.java and string testing and I think some class length of strings, house and house driver. I'm moving all of those there. So that where I wanted to. Let's try it again. No. One more time. Third time's the charm. Or not. Okay. So I'll do that outside of class, but the idea is I want, because currently my source folder is extremely unorganized. Like it's got all of these files here, and I don't want them all here. So let me make like an object examples folder. And then here I'm going to put ComboLock and refactor, house, put ComboLock driver in there as well. Professor and seminar, and also seminar demo. Those all go in there. Okay, and then I think I just have to save these. So now it's still not perfect. I've still got files that are just hanging out here. But the goal is for me to be able to go 6 months, a year later down the line, look at this folder and be like, oh yeah, okay, these are all the files that are related to getting input output. These are all the ones where I was showing here's examples of objects. And so we want to have our code organized in a way that makes sense for us to look at and for an outside observer to come and look at our code as well. Okay, so once we have all of our code organized in packages, there's some visibility restrictions. So if we've seen for fields, we can have public or private. We also don't have to have it be public or private. We can just leave it blank. So like instead of public int x, we could have private int x, or we could just have int x. That's an option too, but it means something. And so having no visibility modifier there means that the field or the method or whatever is package visible. And that means it's directly accessible by anything that lives in the same package as this file. So like for ComboLock, where did I put it here? So if I decided to make my N1 package visible instead, then any class in this folder, in this package, can directly access N1. So we wouldn't really want this behavior, but that's how it works. So over here in house, I could, if I have a ComboLock object, I can say c.n1 and get that directly. What do I want to do? Private. Yeah, so as opposed to public, so if something is public, then anything in this package and outside of this package can directly access it. Private meaning it's invisible to something outside of this file. So yeah, so that's, if we don't have anything there, we don't have public or private, that means package visible. We can also have a class be private. That just means that we can't, yeah, I mean, I actually don't know if a class be private. Oh yeah, so hold on, I'm staring at this chart, trying to remember. Oh yeah, okay, so yeah, so classes, I think classes technically could be private. I think the best option would just be package visible or public. We can't have a private top level class. We'll talk about what a top level class means in inheritance. But basically we can make a class public and then we can use it outside this package. And so you see that in the labs a lot, like let me open this. So like, let's go to baseball tests. So you'll see that we've got a package called main, we've got a package called test. And so these are all public classes, and so I can access main.team and main.baseball. So that's how I'm accessing the team class and the baseball class outside of the main package, because I'm over here in the test package. So we've kind of been using this all along, and now we're starting to talk about it. So this is kind of telling you if something is public, who can access it? Something in the same class, yes. Something in the same package, yes. Something in a subclass, which we'll talk about what that is. And then something outside of that. Protected, we'll also talk about no modifier, which is package visible. And so you can see that you can access it within that same class and within anything in the package, but not necessarily in the subclass and not necessarily outside of that. Okay, so here's what we've talked about so far. We've talked about what's an object, what's a member of a class, what's a field, what's a method. So these are all terms that you should be starting to get familiar with by now. And then there's also, should fields be public or private? What's a constructor? Can we have more than one? Why would we want more than one? And then what are setters and getters? So if you have questions on any of these questions, if you don't know the answer, let's talk. Because we should be starting to get more into the terminology now. We talked about how to print information about an object with toString. We talked about how to check if two objects are equal to each other. We talked about the very important this keyword. We've talked about the main method, talked a little bit about static packages, and then visibility. Who can see this information that we're working with? Okay, what questions do you have about all this stuff? Okay. Let's see, it's 2:53. Do I want to go into chapter 4? Maybe. Okay. We're gonna go for like 7 minutes and then I have an activity at the end. Okay, so we should now have a grasp on what are classes, what are objects. Now we're going to get into the more complicated object-oriented things that Java lets us do. So the first one being inheritance. So let's say we have a class called person. So I'm going to close this window. There's a lot of stuff open here. So I'm going to make, let's see, let me make a subfolder called people in my object examples package. And then I'll say person.java. Okay, so now I've got my person class. Let me clear this all up. And let's say to model a person, there's many things I could choose, but for our purposes, we're going to have each person's going to have a name. They're going to have an age. They're going to have an address, and let's say a phone number. So name, age, address, and phone. And so from here, I'll just let me generate the constructors. Wait, no. I messed up. Source action, generate constructors. Take all of them. And then I want to generate a constructor with none of them. And then I will give it just my default like empty person for my 0 parameter constructor. So I don't actually really care about the implementation of this class. This is just to kind of get us going. Yeah, question?
So if I didn't put public there, it'd be package visible?
Correct. Yeah, we would only be able to create a person object within if we were in a class in the same package. Yeah. And the other thing I'll do is I will generate my getters and setters just for all of them. And that's fine. Okay, so we've got our person set up. So a very basic class to capture some basic information about a person. So let's say we wanted to make a student class. Like we've got a person class. Let's say we want to make a student class, and maybe we want the student to have all these same fields, but maybe just add GPA or add like a list of courses. right? So the code is going to be really similar, correct? Because we've got our fields set up, we've got our constructors, we've got our getters and setters. And so one option is to just like make a new class, maybe like copy all of this code, copy all the code and paste it into a new student class. Sounds good? The answer is no. So I'll go back to the other slides. So the easy way, but the bad way, is to just copy and paste all the code and then change the little things like add a GPA field, add a GPA getter and setter, add and make the small changes to the constructor. That's an option, but I don't like the implications of that, because if we've got some code that's bad that maybe we haven't looked to and gotten around to fixing yet, if we copy and paste that code, we are copying garbage and bring that garbage along into our new pristine class. And so that's like kicking the can down the road, where we've got an issue and we're not addressing it and we're bringing it into this whole new file. The other option is like, what if later we decide I want to change how the name is stored? So maybe instead of like Sarah Roscoe, we want to change it to Roscoe, Sarah. Or somehow change like the format of it, or maybe the address. If we do that, then we would have to go to the person class and the student class and make those little tiny changes. And that's going to get tedious really quickly. And then the other issue with that is that the classes that we made, the person and the student, there's no relationship to each other. So they have like a lot of the same code, but the classes are distinct. So there's nothing linking them, even though they're representing, you know, like the same exact information. So this is what we're going to get to with inheritance. So the idea is that it's going to help us reuse code without retyping code. It's going to allow us to extend the functionality of some code that we write. And maybe later down the line, we say, hey, I like that code that I wrote. I want it to be able to do this and something else. And it also helps us to maintain and update it while not throwing away all the code that we worked so hard on. So that's what we're gonna get to with inheritance. Okay, so we'll talk more about this on Tuesday, but we will. So I think I'll stop here for now. For active learning today, I want to give you a little bit of time for it. If I can go and find the assignment. Today's the 19th. Yeah. So I want everybody, there's a Google form to just like, you'll have to log into Google and just write your name, and then I'll go through and match it with the submissions and then in SpeedGrader. And just kind of like a survey of how are you feeling about the class. And yeah, so rate it on it's like the strongly disagree to strongly agree scale. Tell me anything that you want to know about how you're doing, like self-reflection, and then give me suggestions for how to improve the class. So we have about 10 minutes. It shouldn't take you that long, but I have 10 minutes set aside for you to work on this. And then once you're done, you're free to go or stay and ask me questions.